Hey Joyce, this is kind of far away, so hopefully you have the hard copy that we had to hand in class, and it'll be easier for you to just look at that and follow along. But to show you where the order is, I'm just going to point. But the page that I gave you should be numbered anyway, so hopefully that'll clarify anything. All right, so let's get started. So I just want to give you a little background on our experiment. There was a study done in Udine, Italy in 2010 at a university, and it was found that low-intensity exercise was more effective for weight loss than high-intensity exercise. So what they did is they took a group of 20 adolescents, 20 obese adolescents, and they split them up. 10 of them were on a 3-week regimen for low-intensity exercise, and the other 10 performed high-intensity exercise for a certain amount of time. And those were the two experimental groups. So it was found in the end that the participants of the low-intensity exercise program lost 37% more weight and fat than the people in the high-intensity. The authors of the study tried to justify this by saying that those who engaged in low-intensity exercise burned more body fat, as opposed to those who engaged in high-intensity, they burned mainly carbohydrates. So we'll see if that's faulty reasoning by doing this experiment. We'll see if there's really a difference between low intensity and high, and if one is better than the other, one is more effective. So let's talk about the physiological effects of low intensity and high intensity. So the response to exercise is dependent on the intensity, duration, and frequency of the exercise. So you may not expect to get much of a workout from, walking at a slow pace as opposed to, running on a treadmill. So this means that generally the more strenuous the exercise, the more your body has to work to get oxygen to your muscles, right? To pump blood to the rest of your body. So it would make sense for your heart to pump blood faster. So our hypothesis for this was low intensity exercise and high intensity exercise will show a significant difference in the change of heart rate from resting till after exercise. We predicted that high intensity exercise would show a greater increase in your change in heart rate. So let's talk about what exactly we did, our methods up here. So before I get into the steps, we did have a positive control. Positive control is the change in heart rate after 1 minute of resting. Another control was each subject used their dominant hand when using the pulse meter. The pulse meter was the instrument we used in lab, and it just strapped onto your finger and hooked up to a machine. We were able to get pulse rate and heart rate from that. So let's start with low intensity exercise. So before beginning, everyone took their resting heart rate. So there were 4 different individuals, and we each used ourselves as our own trial. So 4 individuals consisted for 4 trials. So first for low intensity exercise. We did crunches for a minute. So each individual got on top of the desk because we figured that was cleaner than the floor. And we all did crunches, and we were timed for a minute. And then directly after that, our pulse was taken with the pulse meter immediately after we were finished. And then the difference was determined between the resting heart rate and the new heart rate. Subject 1 would go first, and they would have a minute of their low intensity. And then while they were resting, the next individual would go. So each person had to wait at least 15 minutes, actually exactly 15 minutes, before they could proceed to the next experimental, which would be being tested for high intensity. So if that's unclear, we'll just keep going. Hopefully I can say that in a better way. But so we did the same thing for high intensity. After all 4 subjects went and their changes in heart rate were recorded for low, we moved on to high, which consisted of jogging in place for 1 minute. So the first person to engage in the high intensity was essentially the first person that did the low. So by then 15 minutes had passed and their heart rate was brought back down to resting. So each of us, one by one, all 4 of us, did 1 minute of high intensity, 1 minute of jogging in place, and immediately after that, our heart rates were checked again. And I forgot to mention, right before we started the high intensity experimental group, we each once again took a new resting heart rate. So before each experimental trial, we had a new resting heart rate, because each time your resting heart rate isn't going to be the same. But to make it uniform, we started at a new low resting, and we just made the change from that. So as far as our data analysis, a majority of the data we collected was the heart rate, which was in beats per minute, which was given to us by the machine. So to analyze this, we reported the differences, and then using a single factor ANOVA and Microsoft Excel, we were able to take all of our data and average it together and put it into an ANOVA. And the point of using ANOVA is to tell you whether there is a significant difference among the averages that you are testing. And that's pretty much all it tells you. We use the single factor ANOVA and t-tests to determine whether changes in heart rate are significantly different. So the point of the ANOVA was to tell us, okay, is the mean significantly different? The t-tests specifically tell us where exactly they were significantly different. Was there a difference only between low and high, or only between high and resting? So that pinpoints the significant differences for you. So that's why we use both of them. Okay, so our results. This isn't in color, but yours is, so hopefully it looks better when you're looking at it in front of you. But this figure displays the average change in heart rate among all subjects for the different variables. So this actually displays what was expected. This high intensity showed the greatest change in heart rate. This low intensity in the middle was in the middle, as expected. And the control showed a little change, but with a positive control, you expect, you know what's expected because it's not being exposed to the experimental group. So there should have been zero change. There was a little bit of a change, but not enough to mean anything. That could have been due to absolutely anything, but we'll analyze that later. Okay, and down here are individual graphs for each individual. So it's this on a smaller scale. This is a graph for Aaron, this is for Eric, this is for me, and this is for Ayushi. And as you can see, all of them look pretty similar. There were no evident trends, but if you look at this last graph, which is Ayushi's graph, you could see that she overall had the lowest changes in heart rate. That could be for any reason, so we'll get into that later. That was really the only thing that we noticed. There were really no trends or consistencies. Okay, and then that was mentioned again up here. So Ayushi seems to have the lowest average change in heart rate for the experimental variables. Raquel, me, I seem to have the highest average change in heart rate, and there seem to be no evident trends. So to conclude, typically athletes have a greater stroke volume than those who are not athletes or those who are less fit. So this actually, now our results sort of make sense, because if you look at Ayushi, she had the least overall change in heart rate, most likely because she is a dancer, she is physically fit, and she very well could have been the most physically fit one out of all of us. So her results make sense. Raquel seemed to show the highest average change in heart rate. So this could indicate that I'm the most out of shape. That could be a reason. So let's keep going. So let's analyze the tests that we use. Specifically, when you're looking at an ANOVA, you want to look at your F ratio and your F critical values. This is how you interpret, all of these numbers in the chart. This proved that there were indeed significant differences in the average change in heart rates because our F ratio is greater than our F critical, and that's what you want to be able to accept your hypothesis, accept your prediction. The t-test, this test showed where the significant differences were exactly. So we did 3 different t-tests. We did between the 2 controls, and then each control versus the positive control. Each experimental versus the positive. So this also caused us to accept our hypothesis. Our prediction was correct in that high intensity exercise showed a greater increase in heart rate from resting than low intensity exercise. Perhaps high-intensity exercise is indeed more effective. Possible human errors could have included relative non-alignment like that. Okay, let's talk about future directions. So, in the experiment done in Udine, Italy, only obese individuals were tested. So, this could lead to a result that's not really conclusive. If this study were to be done again, a similar study can be conducted in which you have 2 groups. So you should take a group of obese individuals, take a group of fit individuals, and see if their averages are similar. I think that would be a better experiment.